Right. Доброго дня. Сьогодні ми будемо розповідати доповідь Dragons in a Mixed Reality World. Доповідь буде англійською мовою, але якщо у вас є якісь питання, ви завжди можете підійти до нас ще раз і запитати українською, англійською, російською та німецькою. Тому, будь ласка, будь-якою мовою, яка вам до вподоби. А зараз переходимо на англійську. So, ladies and gentlemen, I'm very happy to see you at our topic, Dragons in a Mixed Reality World. And first, let us introduce ourselves. My name is Melashkina. I am software developer at MediaLesson. I recently moved to Germany and working at Munich, but I really want to share my new knowledge with Ukrainian community. And this is Philipp Bauknecht.
Hi, I'm Philipp. I'm a CEO at MediaLesson. It's my very first time in Ukraine and Kyiv, so I'm super excited. Actually, I arrived here 1 hour ago from the airport, so I'm still just in. Besides my role at MediaLesson, I'm also a Microsoft regional director and Microsoft MEP. I do specialize in Windows development and cloud, so if you have any question regarding some broader Microsoft topics, do not hesitate to catch up with me afterwards and have a chat.
Right. So let's start. First, I want to ask you several questions. Please raise your hand who has ever worked with HoloLens. 1, 2. If you have never worked with HoloLens, there is a Sigma software, and you might try it at 5th floor. So, next question would be, please raise your hands who has ever worked with Spatial Anchors or Azure Spatial Anchors. Okay, no one. So you will learn something new. One person. Nice. And do we have any Dragon experts here? 1 expert here, and 2 and 3. Nice, good. So this is our plan for today. First, we will talk about mixed reality and HoloLens. Philip will introduce us HoloLens. Then he will take technical part and tell us about spatial anchors and what is Azure Spatial Anchors. Then I will take over and we will have practical part where we will take a look what tools do we need, and we also will have live demo and I'll guide you through code. Then we will give you some tips and tricks and some things that you should consider when you're working with spatial anchors. If we will have time, we will take a look in usage scenarios, and then for sure we will try to answer your questions. And now I give this to Philip, and the stage is yours.
All right, let's start with the stuff on top of it, like a head-up display or very simple 3D content. And on the far right side, there's virtual reality, where you use a class that's completely shut off from your real world and you are fully immersed. So you can go on a roller coaster ride and be in a whole different setting. And in between those, there's lots of different devices, one of that being the Microsoft HoloLens, which can operate in various modes. So HoloLens can be in an AR mode, and it can also run in a VR mode. And the interesting thing about HoloLens is as it has way more sensors than your normal mobile phone, it has a far better understanding of your physical world. It makes it much easier to blend the digital and the physical world. Because ultimately what we're always trying to achieve when building something from mixed reality is have this really nice integration of the physical and the digital world. So it feels natural to have a hologram sitting somewhere and interacting with that. So that's what we call the mixed reality spectrum. As you may have heard, there's a new device coming up. What we have here today is a Gen 1 device. It's the first HoloLens. And right around the corner, hopefully not too long from today, will be a second generation of the HoloLens. And to give you a first idea of how that may feel, I have a small video. Let's see if that works. Looking good. So it's been completely redesigned from the ground up. Has lots of shiny new sensors and display technology built in, and it addresses some of the biggest challenges of the first generation. Who has tried it? You might have recognized the first generation has a very limited field of view, so it feels like you're boxed into a monitor, and that has been very, very much improved. Also, the comfort of wearing it, so they put a lot of effort into that one. And you can basically now wear it like a helmet. The Gen 1 device still has a ring that you need to adjust and stuff like that. That will be gone on the second generation. So what you can see here already, and that's a very critical part of the holographic experience, is the holograms that are shown in this video. They are very static and solid, and they are almost like they are married into the physical world. So they don't shake or anything. And that's at the core of the mixed reality experience, is that you have holograms that are static and that are really tied to the underground or the physical world. If you lose that feature, if holograms start moving around, you lose all the immersion right away, because as soon as stuff is moving, you feel it's a digital layer. It's not glued to the physical world anymore. So some of the improvements of the second generation is it has 2 times the field of view, so it's much wider and much higher. It now has hand tracking. It basically sees your fingers, and you can actually touch holograms and interact in a very natural way. Whereas the first generation, you had to learn some gestures, like air tap, bloom, and stuff like that. So that's gone. What's very cool is it has eye tracking, so it has a camera that sees your eyes, and that helps in numerous ways. First of all, you can use it to actually log into the device as authentication, but you can, for example, scroll through large lists just by moving your eyes. You don't have to do any physical interaction with your hands anymore. And you can also use this for user research, because if you have something that's watching your eyes, you know pretty precisely what the user is looking at. So that's a nice little side feature that comes with the device. It has a super powerful CPU and GPU, and it has some neat features like remote rendering, because if you're using a mobile device like a smartphone or a HoloLens, there's always a limitation on what you can actually render on that device directly. It's very, very limited. Think about hundreds of thousands of polygons, whereas, for example, if you would want to display a 3D model of a car that's physically accurate, you would talk about tens of millions of polygons. And so to bridge that gap, they introduced a technology called remote rendering, where you render on your physical machine. Can be a beefy laptop or even a cloud service, and then stream that to the device. Now, I was talking about having this really solid hologram sitting somewhere, and at the core of that is a technology that's called anchoring or anchors. The idea of an anchor is that if you have a digital object and you kind of tie it to a physical location, it cannot move anymore. And the anchoring in the case of a HoloLens is basically done with several sensors at the same time. So it uses a camera, and it uses a time-of-flight camera with depth sensing to do that. But the interesting thing about anchoring is that it basically works on almost every phone as well, because there's a technology called SLAM that allows us to do it purely by using a video camera. And I want to dive a little bit into how that works, because that's the base technology that we're going to use in the following demo and in the Azure Spatial Anchor service. So a spatial anchor is basically a common frame of reference to place digital content into a physical location. So basically, I'm looking somewhere, I'm getting an X, Y, Z coordinate of that point. And if I move my device, it still stays relatively at the same location because of the sensors of the phone, for example, gyroscope, magnetometer, the video camera, it can adjust the position relatively to the viewer. Now, this is usually done by the operating system itself. So in case of HoloLens, it's part of the mixed reality platform. If you're using iOS, it's called ARKit. If you're using Android, it's called AR Core. It's basically operating system features. You don't need to take care of that. So you can then place, for example, a rocket or whatever you like at a certain location. Now, what the camera sees, this is a little example video of a very basic AR application as seen from a smartphone camera. It basically, you can see it from the little white dots. It recognizes planes or surfaces on the floor. And if you've seen enough, you can just click it and you place it, and then you can move around and it stays at the same position. This is done by a smartphone, so even with a pure video camera, this works fairly well. Unfortunately, this is good enough for doing local anchors. Local anchors meaning I'm starting an app on my smartphone, I'm placing something somewhere, and as long as I'm running the same session on the same device, it kind of works. But as soon as I restart the app, it all starts from the beginning. I need to replace it somewhere again. It won't stay at the same position, so it's not a persistent anchor. It's kind of a local session that's running. What we ultimately want to achieve in this session is to show you how to create persistent multi-user anchors that live across multiple devices so that you can create experiences that are multi-device and that can go on for a very long time. For example, if you are at a theme park, you can have a virtual guide that shows you around the theme park because someone has placed those anchors like breadcrumbs across the theme park, and other people can pick up those anchors. So to do this, we need to have more information about our environment. So if you're looking at this picture, for example, there's a lot of stuff going on that picture. There's a couch, there's a little table, there's some stuff in the background, so it's a very, very distinct visual picture of a location. And based on that picture, we can start collecting so-called feature points, visually distinct markers in a video frame. And if we collect enough of those feature points, and if we look at them from different angles and sides, we get a very, very unique reference in a certain location or room or space. For example, if I would look at the same pictures and then start moving my smartphone around or my HoloLens, I'm getting more and more of those feature points, almost like a point cloud. And those get, the longer I collect those images, the more frames I have, the more precision I get, the better the idea is of where I'm at the moment. And so in order to have a true device-independent spatial anchor, we need to collect as many of those points as possible. And if we do so, we can create a so-called cloud spatial anchor. A cloud spatial anchor starts with the same idea. I'm looking at a certain point, and if it's interesting enough for the camera, if there's enough of unique points in that, I can then start having a second user and a cloud instance, for example, Azure Spatial Anchors. It's a cloud service running in Azure. And I can use the point cloud that I'm collecting on the first device, send it up to the cloud, store the point cloud there. What's really important from a data privacy perspective, though, is never leaves no video or image frame leaves the device. It all stays on the device. It's all processed by the native AR platform, ARKit, AR Core, and HoloLens. And only the point cloud that gets collected out on top of that is what's being sent to the cloud instance. So if you're worried about, hey, I don't want to film all my rooms and have it all stored somewhere in the cloud, basically the only thing that gets stored is something like this. So it's not as heavy as having true video frames. And then if a second user starts a session on a second device, I can then start searching for anchors. To do that, I need to know which anchors I'm looking for. If there's 1 million anchors in this room, obviously it won't work because it would require me to download 1 million anchors on a device. So there's certain limitations to that technology. At the moment, the limitations is I can look simultaneously for up to 10 anchors in a session. So that's kind of my starting point. And as soon as I'm finding the reference, I will see the same hologram at the same location, but relatively to my personal perspective. So I might see it from the other side if I'm standing on the other side. What's really, really cool and what excites me about this technology is that it's not limited to the HoloLens, because as we all know, HoloLens does not scale very well. It's really expensive, and even if you want to buy one, no one will sell you one at the moment because, they're still building it. I don't know. So what's really cool is this is a cross-platform technology. So it runs on Android using AR Core, and it runs on iOS using ARKit. And you have various options on how you want to develop for this. If you are a native guy, you can go C++ WinRT on HoloLens. You can go Java, C++ on Android, and you can go obviously Objective-C and Swift on iOS. But the interesting part obviously is going multi-device and cross-platform. And so if you want to be on the smartphone side, you always have the option to go with Xamarin, use .NET C#. There's an SDK for that. Or if you want to include devices like the HoloLens or other AR devices, you can go Unity, which is also running C#, which is nice, and all can target this Azure Spatial Anchor service. That's kind of the high-level pictures. We want to have a multi-device AR experience, and to do so, we need to create spatial anchors, and we need to have a technology to somehow share those spatial anchors across multiple devices using this cloud service, Azure Spatial Anchors. And with that, I'm going to hand over to Anna. Hopefully you're still there. That's good. Didn't leave me. And she's going to show you how this actually technically works and how the code for that looks like.
Right. Thank you very much for technical part. Let's switch to practical part. So this is our application that we're going to develop today. We do have HoloLens, and we do have mobile phone with AR Core. And what we want to implement, let's say we have one user that has HoloLens, and he places model, in our case it's Dragon, places Dragon somewhere, and we have another user that has mobile phones. And as soon as this model is placed, it should be automatically downloaded to mobile phone, and you should see automatically update. That's what we're gonna implement. What do we need for this? Well, first of all, you need to have Azure Portal account. And you need to have Spatial Anchors resource in Azure Portal. You have to create account ID and account key and get it from Portal. You need to create Unity project with XR enabled and install Windows Mixed Reality package. And for sure, you have to have several devices like HoloLens or Android or iOS device that support these platforms, these SDKs. So it might be that your device already supports it, and if you want, after the talk, we always can try on your device as well. It's good. I've already done all these steps, so we do it right now. And let's switch to demo. But first, before we switch to demo, I will guide you through code and will show you how this demo actually works. So for this, we need Unity. One more question, who has ever worked with Unity? Okay, so almost half of people, that's good. So I do not need to explain every single part. But for someone who don't know what is Unity, Unity is game engine, and normally it's used for game development, but it can be also used for mixed reality development. In Unity, we have scene, and on scene, we have several game objects. Directional light is just usual directional light, so it's not interesting for us. But camera parent, this is one of game objects that's really interesting for us. So camera parent is camera for several devices. One is HoloLens camera. Let's go inside here. So HoloLens camera is basically where user head is. So head is camera. Another thing about this camera is that it has black background, and HoloLens transforms black background into transparent color. So this is how HoloLens camera works. We also have Air Core device camera. So this camera is camera that is used of your mobile phone. Another thing that I want to show you is this debug log. When I was developing this application, it was in August. There was one open issue. Right now it's closed, but I'm not 100% sure that it is resolved. And problem here was that it wasn't possible to debug at all. For someone who has already worked with Unity, normally when you want to develop something, you have here a play button, and when you want to develop, you put breakpoint and go to Visual Studio. This is normal development. Well, not for spatial anchors, at least used to be. Problem with spatial anchors is that you cannot debug at all or couldn't debug at all for mobile devices. And you could debug from Visual Studio, but only after you build your project and get UWP project, which is running on HoloLens. So don't be afraid if you will see this debug log. Normally, it's for me, so that I can see if everything works or if application hangs or whatever. Just that you know. And last, spatial anchors. This is completely empty game object. There is nothing special here except this small script. Here we have Dragon prefab. So this is the model that is used for Anchor, and you for sure could use any model, whatever you want. We could use cubes or spheres, but it won't be so funny if our presentation will be called Cubes and Spheres in Mixed Reality World, right? So dragons are funny. And let's go inside to the script and check what it does. So I created this file. It contains several scripts, and for HoloLens and for Android, normally you won't do like this, but this is only for demonstration. And we're not gonna have any live demo coding. I will just guide you through code and highlight several interesting things. Let's start with HoloLens. In Unity, we have start and update, and start is called before any frame, and update is called on every frame. What we do for HoloLens, we create cloud session. And cloud session is Cloud Spatial Anchor session, which has Anchor ID and Anchor key. So these two values you get from Azure Portal. All other stuff, it's just for debugging and so on. Next, we capture gestures. So here's HoloLens captures gestures, and here we try to capture tap. Tap is like click, when you do like this. This is tap in HoloLens. And when you create some click, what we will try to create raycast, and we will try to get out what is the point where you clicked. And if we could get this point, we will initialize at this point local game object and then create anchor. How does it work? Well, this is interesting because first of all, you need kind of lock your game object. When I'm saying lock, if you worked with Unity, you definitely know that game objects have normally transform and position. So when we lock game object, we cannot move it anymore, and you cannot update position. Yes, you can set something to position, but it won't be updated. This is what is lock. After this, we will create Cloud Spatial Anchor and gate pointer, here, gate native anchor pointer. After this, we will send it to Cloud Session and create anchor. When it's created, it gets identifier. Identifier is global unique ID. And here is storage service. Storage service we wrote on our own. Let's go here. So here I used for storage service Azure functions. What is Azure function? Has anyone worked with Azure function? 1, 2, okay, better, that's good. So for people who do not know, Azure Functions is serverless solution, and it runs only when code executes. And here, what I'm trying to do, I try to save this ID to Azure table, and basically that's it. So here, there's nothing very special. It could be any data source what you want, SQL Server or Cosmos DB, whatever, this doesn't matter. The only thing we need to store somewhere ID.
Anna, maybe to give some context why we have a function now, because we're building something local, is the way Azure Spatial Anchors is designed is you can save an anchor, basically this point cloud, and what you get back is simply an ID. So there's no other metadata or any other thing attached. It's just I throw a point cloud in, I get an ID back. Now, I need to do something with that ID, right? Because I want to associate it with some own data or model or whatever. So that's why we wrote this little backend in Azure Functions that just saves the IDs and gives us the IDs back. Because in the second session, we need to look for those IDs, so we need to get them from somewhere. And it's a separate device. We need to get it from a cloud instance. So that's the reason for that.
Mm-hmm. Thank you. And after it's saved, we can unlock game object. So this is HoloLens part. Let's go to Android part. Here it starts a little different. First of all, you have to run in your Java. And without Java initialized, it won't run. So be careful here. If you will try it at home, please make sure that Java is running on your phone. And only after that, you can create Cloud Session. Right. I'm a bit lost here. Now let's go to update. So here we have to process last frame, because that's how mobile devices are working. They have always checked what is the last frame. HoloLens do not need this last check, because HoloLens is scanning your room always as it's running. And next is kind of easy solution here. What we're gonna do here, we just will check each time if something has changed, each second. If something has changed. Well, normally, if we will have running server, we will have WebSockets that will send us ID and so on. But this is just demo. That's why we will take easy solution and we'll just ping server each second. And the next thing, this is scan%. So scan% is also an interesting part. Your room should be scanned more than one, and one means for sure 100%. And only after that, anchor can be placed or loaded. So also take care of it and make sure that your room is scanned enough. And when room is scanned enough, we will try to load Anchor. So here we have Anchor loaded criteria, and this criteria has Anchor ID. Anchor ID we load from Azure function, just as we did it. We posted to Azure table, we will load it from Azure table. So here, nothing special. And if ID is not new, well, we won't do anything. If ID is new, then we will try to load something. Here I want to highlight also this part. So there is limitation of current API that only one voucher is available. So you can download several anchors, but you cannot change these anchors dynamically. And if you want to change them, you need to stop voucher and start new one. So this is also, be aware. Criteria has only one anchor. We create voucher based on this criteria. And after voucher is created, at some point of time, anchor loaded event will be fired. And if anchor loaded successfully, we will spawn or move anchor object, which is our game object. That's all for code part. And now let's have live demo. Right. So at the right side, I have HoloLens live streaming. And on the right side, vice versa. On the left side, I have phone, and on the right side, I have HoloLens live streaming. Right, so let's first stream from HoloLens. I want to highlight that this functionality is still in preview, it's not even beta, so if it won't work for the first time, we will try to run it for the second. Right, so here's streaming HoloLens. And
we are not recording.
So now we will stream from phone. Here's my phone. I give it to you, and when I will place anchor, this I will close. When I will place anchor, you will run application and try to load it. First, I will scan room, if it works. Okay, now. I will try just to scan it before we start application, so it won't crash because of not enough special data. Okay. So that HoloLens know where we are. Now, meetup. Let's wait. We need to give it the time. This is loading screen. Okay, this is our debug UI. That's what I'm looking for. Session was initialized, so good. Now I'll try to put it somewhere here. And I need to move my head around and wait until it saves position to server. Okay, position is saved to server. So now you can try to run application and try to move mobile phone somewhere around here, and it should load model without any further updates.
Let's see.
In any case, we always have video.
Did you walk around more? Says the room is scanned. Oh, there we are.
Nice. So I can try to move it somewhere here, and it should be updated automatically. Let's see. Okay. So it moved. Now I need to wait until it's saved to server. Server will create. Nope. Not yet. Maybe I can try from this point. It takes time, you know, give it a time. Okay, saved position.
Oh,
right.
there it moved. Mine moved right away.
Worked?
Yeah, that worked.
That's good. Okay, now back to presentation. Where did we stop?
You can
Demo. Right. Well, so this is my personal opinion. Some further possibilities, what can we do, what can be improved? First of all, I think that it might be useful if we will have one more watcher, or not one more, a lot of watchers, not only one. Second thing, you didn't see that I was deleting anchors. And I want to say that it's possible to delete anchor, but the problem is that you have to first load anchor, and only then you can delete it. So this hurts performance, very hurts performance. Next thing, you cannot delete all anchors at once, and it might be helpful if you can just clear your storage when you want. Another thing for improvement, you cannot update anchor. You have to first delete anchor and create new one, but you cannot update already existing anchor. And for sure, we have to have more accuracy. Right now, it's working, but for example, if you do not have enough light, or if something changes, you will see some drifting of model. So there should be more testing and more accuracy. And some tips and tricks, UX considerations. First of all, you might think that when we started creating anchor, we started from this point together. So I was seeing this stage from this point, and Philipp was trying to scan from this point. And that you have to take into account, that if you will try to scan, for example, from different points of view, you will find anchor, but it will drift still somewhere. So please make sure that you're scanning from one position. So you have to think where your user will start to scan and give him a hint, for example. And another thing that you should take into account, that your room should be full of something, whatever, furniture, people, better furniture. The problem here, if you have empty room, it's not enough spatial data, it's not enough feature points, and you just cannot load anchor. You just cannot load it. Right. So this I've already said. So make sure that you say your user where he or she should start. And now we have enough time, right?
Yeah.
Okay, fine. So I switch back to you. Usage scenarios.
All right. So now we have something that's technically kind of cool. It kind of works. Now, what to do with it in a useful manner? That's the question now. Basically, there are two main scenarios that you can achieve with spatial anchors. The first scenario is around the generic persistent multi-user virtual content. For example, imagine you're doing a design review, or you want to discuss on anything that's 3D. It was super cool to stand around a table and then see it from different angles. This is something that can easily be adjusted for different industries. For example, we are currently building an app for a car manufacturer for their dealership, where you could walk to different cars and have a digital overlay on top of the car explaining the features, the price and everything, so they don't have so much clutter anymore in the dealerships with physical displays. The idea of having a digital twin is not new. It's kind of one of the core foundations of doing industrial IoT. But actually having a real digital twin that's physically glued to the actual object is a whole different level of having a digital twin, obviously, because you don't have to locate the object. Whereas a regular digital twin, how we use it in IoT, usually means that we collect some sensor data of a machine, for example, and then have it on some sort of dashboard, but you don't know where that actually sits, because you don't usually have one machine, you would have like hundreds of machines on a shop floor. And actually seeing the data where it's coming from is a really nice improvement here. In all kinds of training scenarios, so this is a sample video of a training AR application also for a car manufacturer, where you would learn step by step how to assemble a seat. Now you'll see in a second that this is kind of cheating what they're doing in this application. So it's giving me step-by-step guidance on the real physical object, which is really cool. But in the end, you may notice that it's not really using any spatial data. Basically what it does, there's kind of a QR code marker on the physical object that helps the camera start the session. Well, obviously that's easy to do, that you can do it without any AR technology, just scan a QR code. But that's not feasible for most usage scenarios, because you have to convince whoever's running this factory to equip all their machinery with QR codes, and that kind of takes the whole magic out of the story and makes it less attractive. So doing the exact same thing without that visual marker, just because I realized this is a seat type A, and then apply the training material on it, that's what's really cool. And then the other class of application that becomes possible, that's kind of a little bit more complex, is actual indoor wayfinding, which can be problematic. For example, this is a picture of the Boeing factory in Everett, which is the single largest building by capacity in the world. Imagine you would have to navigate as a new employee or as a guest through that building. And the interesting thing about Azure Spatial Anchors in this context is that if you have a starting point that can be an anchor, you can have multiple anchors that are connected to that first anchor. Because what Spatial Anchors allows you to do, and we didn't show you that yet, is you can have edges along multiple anchors. So if you have a first one, it's like a breadcrumb. You can see, okay, from here over there, there's a second anchor, and you just guide the user there, and then you can, okay, there's a second anchor, and you can guide people through complex buildings purely based on visual data of the camera. There's no Bluetooth, wireless, GPS, or anything required. So it gives you indoor wayfinding without adding something to the location's infrastructure, which is really amazing for those kind of scenarios. And you can imagine, obviously, also guiding people to machinery or navigating warehouses, navigating large shops, shop floors, just by adding that extra visual layer on top of it. So I guess that's, for most part, what we got for today. There's lots of resources already. Microsoft's providing SDKs for Xamarin, for Unity, and for all native platforms. So you can choose whatever development style you actually want to build those kind of applications. And then if you have any questions, please do not hesitate and ask. Yeah. Oh, there are multiple questions now. Do you need a microphone? Okay.
Well, right.
Thank you for your talk. I have two questions. The first one is about, you have mentioned a couple of limitations, like only a single watcher, only a single anchor. Are those limitations of Azure or of your demo, and they can be addressed via your source code updates?
I'll take this question. This is practical part. So this is limitation of current SDK. It's not limitation of demo. This is really limitation of current API.
Okay, and on Android and iOS sides, you have devices with single or multiple cameras. Are they used by native SDKs, and does it help to better understand the room, the environment?
Well, they used by native SDK. I mean, cameras are used by native SDK. And what was the second question?
I mean, if the device has two cameras, like wide and zoomed camera, will they both be used or only the main one?
I think when you're using it on a smartphone, it's a pure SLAM algorithm that uses one camera only. The only difference is on the HoloLens. On HoloLens, it uses real all sensors, all the depth cameras as well. That's why on HoloLens it usually works a lot faster. But on the other hand, on the smartphone, the precision is better because the camera of a smartphone has a multiple times higher resolution than the HoloLens camera. That's why the image is has much more detail, and that helps with precision.
Okay, thank you for the explanation.
So accuracy scales with the camera resolution at the moment.
Thank you.
There's a question over there. There was one over there.
Thank you. It was a really nice presentation. I just have a simple question. So currently I'm working with microservices and Docker and stuff. Tell me when I have to switch to this new technology because it really looks awesome. I just want to know how long do I have to wait?
You want to use this in Docker or what was it?
No, the question is like how long until this becomes ubiquitous, like when everybody starts using it?
Okay.
Like so, how much do I have to wait until I can get a job working in this industry?
Okay. So, good one. At the moment, the Azure Spatial Anchor service is in preview, as pretty much everything that Microsoft releases initially. It's been in preview, I think, since May. No, that's not since January, so it's due to go into production hopefully soon. But people already built production-style stuff with it, because the API surface, as it is stable. The only thing that's kind of an unknown at the moment is the pricing. So we're not sure yet how it's been priced in the end, but it's just an assumption. I have no knowledge at all about the pricing strategy, but since the cloud part itself is more about storing something and all the calculation stuff tends to happen on device, I would hope that it's as inexpensive as other storage offerings.
Thank you. What do you think, like your personal opinion, how long until this technology, like this is becomes mainstream, something that everybody can have in their households or workplaces?
Yeah, well, so the amazing part for me is that on the user side, it only requires a smartphone, and it doesn't have to be a super high-end iPhone. It works with mid-range Android phones as well. If you look at the compatibility link that we provide from Google for AR Core, it starts with a $100 device already. So it scales really nicely. You don't have to have a special hardware for it on the user side, and that makes it so attractive for us to really build solutions that are not POC. Because if you build something for a device like this, at the moment, it's mostly POC stuff, because no one buys 100,000 of those, but everyone has a phone, so.
Thank you, and I have a very simple question. Have you been using HoloLens 1 or 2?
We've been using HoloLens 1. We also did some stuff with HoloLens 2 already, but nothing to show. But the HoloLens 1 works great with that. So the SDK also works for HoloLens 1.
Yeah, and do you think with HoloLens 2 you would be able to do much more, or is it like more or less the same?
Well, all the sensors in HoloLens 2 are brand new. They're basically based out of the Azure Connect project, so they are much higher resolution. So you can expect to have a lot more performance in regards to tracking speed, but also tracking accuracy.
Yeah, okay, thank you.
Yeah.
Thank you for your talk. I have a question. Do this special anchors technology does it use user's location? You know, I can have two rooms that are similar but are located in different places?
No. So the Azure Spatial Anchor service itself is just about this point cloud thing. But you're raising an important question is, how about I have 4 meeting rooms that are pretty similar, or I have 4 entry points into my building, which anchors to load then? Because you have to initially decide which anchors to preload in order to recognize them. And in those usage scenarios, you would typically have multiple sensors combined. So you could use wireless or GPS to get an initial rough idea where you're starting, and then load those 10 anchors that tend to be in that area to have a starting point. And then once you have the first anchor, the anchoring technology completely takes over. But you would combine multiple sensors for those scenarios.
Okay, I see. So I had another question, but I think I already know the question, the answer to it. Does Minecraft Earth uses special anchors?
I don't know.
Okay, see, thank you.
Yes, thank you for your presentation. I also have maybe a simple question. So we saw this presentation, as I understand, this is like more static experience when one user places anchor and another, after some latency, sometimes sees this anchor. Is it possible, if not now, but maybe some plans for future when users will be able to have some real-time experience with some moving objects, I don't know, interact when object moves, when its parts are moved, and you have like some interaction with the object itself. Is it possible?
So the reason why we had the latency in the second part of the demo with moving the dragon was basically because we updated the spatial anchors. We relocated the spatial anchors. If you want to have a near real-time experience, you would have a same starting point, that's one anchor that doesn't move, and then just stream transforms between 2 apps. And that's basically not part of the spatial anchors anymore, that's just like generic multi-user experience where you say, okay, someone moved it 10 meters over there, and just update all the other participants, and that would be near real time or whatever is possible on your network. The reason we had the latency was purely because we wanted to show you can update the actual anchor, which is not necessary for a game, for example, because you just have to have the same starting point and then just calculate from there.
So like this Azure Spatial Anchor service is not like a golden bullet, it's like one of the technologies that, and if you want to have this real-time experience, that you should combine different technologies, different approaches, right?
So the unique offering for Azure Spatial Anchors is that it makes the anchor that's local and that's not new, that's always been there for AR, and takes that anchor and makes it multi-user, multi-platform by offering a non-platform specific service and platform-specific SDKs, and allows you to persist this anchor across multiple app sessions. So you can create an anchor now, come back in a week, and it would still be there because it's persistent in the cloud.
Okay,
and
thank you.
It's kind of the only functionality it has, but that is really cool.
Thank you very much.
So, thank you very much. Give him a round of applause.
Thank you.